So then the other thing that you can do is for known risk is a quantitative risk analysis. Something to do with mathematical formulas, and you as a project manager, whether you can do quantitatively assess certain risk elements and try to give a monetary value to the risks. So once again, the risk register will be an input because you're tackling with the risk register, and as an input, all your project management plans and the estimates will be an input to you. So let's briefly look at certain quantitative risk methods that can be used. So decision tree analysis is one of the what do you call it, regularly used tools in assessing the outcome. So here the decision tree is actually it's an event based. I mean the risk based. I mean if you have many events to occur, there is a 90% chance the project is success. There is a 10% chance that another event can occur. There's a 10% chance this is going to success, or 90% chance this is going to fail. So likewise, this is where the uncertain decision tree is, where you try to incorporate uncertainty in your events. So for example, a textbook example is this is where you try to calculate in a decision tree in your I don't know whether you've done in your previous study, you calculate the expected monetary value, where say for example you are about to take a decision whether to a hypothetical example with to build a new plant or upgrade the new plant. So in a build a new plant and upgrade the new plant, maybe you have to invest $120 million for the building and upgrading $50 million. And with the product lines, production lines, maybe since it's a new plant, maybe you can do better products, and there's a strong and there's a 60% chance there's a strong demand of $200 million, and there's a 40% chance of a weak demand. Maybe since you're upgrading your plant, maybe it might not be, you cannot do sophisticated products after that as a new plant, but then there's a 60% chance of strong demand of 120 million opposed to 200 million here, and a weak demand of 60 million. So this is where the uncertainty they are taken into account, and at each path you can actually calculate the net path value. And the net path value of here is 200 million sales minus 120 million investment. The net path value of this path is actually 90 million sales minus 120 million investment. Likewise, you can calculate the net path value for each of these paths, and then once a net path value is there, since there's a probability, there's an uncertainty element here of occurring this net path value, you can calculate something called expected monetary value, expected EMV, the expected monetary value. That is nothing but multiplying the net path, multiplying net path value into each path's probability. So 80 million into 60, this 80 million into 60, and this 30 million, this is minus 30 million, minus 30 million into 40. And you can sum up it up and come up with a expected monetary value of this entire path. And here also same wise, 60% into 70 and $10 million into 40%, $10 million into 40%, this is a plus, and you can calculate the expected monetary value of this path. And here basically the most expected monetary value is taken into the decision making. So likewise, these risk elements are here incorporated, and you as a project manager can, in your alternative analysis, you might be able to take these figures into account in ranking your risks and ranking your paths. Examples, there are plenty of examples in the internet, you can see. So it's the same thing. So the net path values are here and already calculated in this example. So you can for the project one, since there is no, so net path value is already calculated, and you can multiply the probability and the net path value together and sum it up and come up with the expected monetary value at project 1 and project 2. So what they have done is they have calculated, they have put the value here by multiplying the probability here. It's the same thing that you calculated, the same thing other way around. And one more example again for your understanding. So make or buy, develop a new software or purchase a new purchase a new software package of system. So likewise, you as a project manager, these are hypothetical examples for you, maybe hiring a resource or outsourcing a development part of your project. So those things can be there. What are the risks involved? And so here the costs are given for develop a new software, this is the amount, and to purchase a new software, this is the amount. And so there can be a 50% chance of a cost overrun, 50% chance of a budget being made, 25% chance of a product being unstable, 50% chance fixes required, which has a cost of, we have to spend another time and material value of 500 euros. Product unstable, you to rectify, you have to spend another 5,000 euros. So for each of these, you can calculate the net path value by multiplying with the each and probability. In this sum, of course, here is 0, so since there is no cost involved, so the multiplication will be 0, same here. And then plus this, you get this figure and this figure from the upper. So the make or buy, basically here of course it's a cost involved. In our previous example here, it was a sales involved, so we took the highest one. Here of course it's a cost involved, so you can take the the lesser part. Basically this can be the best package to choose on. Right. Some other technique, quantitative technique, is actually is a sensitivity analysis, where even what if analysis also called sensitivity analysis. What if, you can have different scenarios and see what is happening. There's a famous diagram called the tornado diagram along with the sensitive analysis, and here the main objective is actually to graphically see what is the most potential impact, the risk, the most risk, and what is the most potential impact to the project. So here of course what they've done is basically, sometimes a risk that here there can be, for a risk, particular risk, there can be various outcomes. Say a certain activity that is getting delayed, you foresee a risk, say a procurement, you're purchasing a shipment to come to Sri Lanka on some hardware. So that there's a risk that shipment can come early on a positive note, and even negatively, maybe a few weeks later. So this is the state we expect. We expect the shipment to come on the 6th week of maybe on 15th of November. So we expect the shipment hardware to land in Sri Lanka by 6th week of November. There can be a possibility of a worst case scenario that the shipment can be in mid-December, or there can be a positive scenario where the shipment can come in last week of October. So for each risk, sometimes you might be able to calculate the monetary impact of it. If it is lands in mid-week of mid-December, this is the cost. That is, maybe you will have to, since you have hired the database administrators, and you will have to pay them and keep them waiting until the hardware is have arrived. Okay, so there can be a cost involved. If the goods come early in October, then of course, since you're anyway paying to them, you can release the fellows, quickly do the database administrative jobs and release the fellows from the project. So there can be a cost saving to the project on this side. So likewise, in each risk, you can have the most probable scenario and the most worst, sorry, the most probable scenario here actually, the most optimistic scenario here and the most worst case scenario here, and see the and give a monetary value and see. So this graph like this can give the stakeholders a snapshot of what is the high impact risks are there. So in this one, the risk number one, a delay in the worst case scenario will give you a larger cost impact, and risk number 6 is a minor risk, positive or negative, there is no much thing involved. Sometimes in a calculation, sometimes the positive side might be more, then of course then the advisor is actually try to take it, try to push the events so that the risk is more into positive side. So this will actually give you a very good clear picture of what is if it is positive, the risk is positive, how much will be the gain, and this risk is going in not in our way, then how much will be the loss. So one more example I just popped up from the internet. Uh, so this will be the current forecast. I mean, if that is as it is for the project schedule, then this is the cost anyway you're going to incur. Uh, if it is a worst case scenario, this is the cost. If it is a best case scenario, this is the cost saving. So the worst case to best case basically. Got it? Right. So one more technique was there actually in the slide deck called the simulation. It is more into statistical. I mean, you could refer certain resources in your when you're free. Monte Carlo statistical methods. So there are various statistical resources that are available to gather the correlation effects, how dependent activities are on the risks. So there are various statistical simulation methods. Maybe you might have to take a help from your research head or statistical guy in doing that. But why I concentrated on these two is actually without any expert statistical knowledge, actually decision tree can be definitely done by a project manager on a basic understanding, and of course obviously this is also no much rocket science of giving a sensitivity analysis on it. Right. So the output obviously is the risk report. You can do a, if you want to do a risk report on the updated information, you can do a risk report, and also the ranking of the risks in the risk register.